Okay, and obviously since we're dealing with geologic time, we need to know a little bit about the geologic time scale. And the videos I have for you show this better than I can, but it's kind of helpful to look at a couple different images of the geologic time scale. Here is one that has it all to scale, which we don't always see. So we are looking at the Earth like a big clock. So if we talk about the history of the Earth, like the hours of a day, so it looks like we're going from 0 to 24 here, so the hours of a day, then the first 3 hours of our day is called the Hadean and is a time period that makes about 13% of Earth history, obviously here, but also we really don't have any geological record of that because the Earth was molten during that time. So the first, half a billion years of Earth history, it was molten, and we don't really have a lot of record of that. We have some ways to deduce what could have been going on, but we don't really have solid rock from that time. Now, as we get through the Archean eon, we are looking at some bacteria. We're looking at some cool stuff going on, but that's going to make up about 1/3 of Earth history. And then we get into the Proterozoic, and that makes up, another 40 or so % of Earth history. And then as we start looking at what we think about as the geologic time scale, we're usually starting with here, 545 million years ago, almost 90% of the way through Earth history. And this is the onset of complex life. Now we do have some weird little wormy type of critters and definitely single-celled life before the Phanerozoic eon begins. But then we start getting trilobites and seashells and other life. And then we go through that to about 245 million years ago. So we're getting the first reptiles, around this time. We actually get dinosaurs here in this slightly orangier section. They go extinct, the non-avian, obviously, dinosaurs go extinct 65 or so million years ago. And then, we're to mammals, the Ice Age and all that at the end, and then here today. So this is the whole scale. If we were to imagine all of Earth history in one 24-hour period in one day, what sections, are we looking at? That's really hard to imagine, and we'll delve deeper into the geologic time scale later on this semester. But I think that's kind of a cool one because it's actually to scale. So we're seeing something similar here also to scale. Again, the Hadean makes up about 15% of Earth history, and then the Archean, and as we're starting to look at these words, pronounce these, we're not together. We can't really discuss and talk about these words. We don't really get a lot of practice talking about these words together, but do try to pronounce them because honestly, and this is an education thing, this is a tip from a teacher, being comfortable with saying words makes us think about where the letters are. It also makes it, and typing these words and actually handwriting them is better, makes us feel comfortable with their meaning, more familiar with the word itself. If you're just seeing the word and listening to me say it, and then you have, by the time the exam comes, you have to write it down or think about what it means or tell me what it means, it's going to be more boundaries between what you're thinking and what you're putting down on the paper or the computer screen. Anyway, I know these are some weird words. We're just getting introduced to them, but we'll be using them all throughout the rest of the semester. So start to feel a little bit comfortable. So I like this because this shows some of the major things that happened throughout the history of our planet. Here's our Proterozoic here, where we have nucleated cells starting to get a rise in atmospheric oxygen. We'll talk about that. That's a big chapter in Earth history. Caused by life, really, caused by photosynthesis. And then we start to get into our complex life here. So trilobites and all that, dinosaurs in this little white area, humans at the very end. So it's kind of cool, this whole semester, and I'm still working on this with myself, we are going to develop a deep time mentality because we're used to thinking in maybe hundreds of years, maybe thousands of years. We're thinking about ancient Egypt and Greece and stuff, but really we're thinking in tiny periods of time that really are just a slice of the very end of this timeline here. Whereas in this course, we're going all the way back to the whole history of our planet. And indeed, this chapter, I'm not going to talk about this because you have it in your chapter, it's covered very well there, is talking about the formation of the universe, which is even far older than the Earth. So get into that too, but I'm starting with the Earth. So one of the things you are looking at is, so here's our geologic time scale, and this one is not to scale, of course, especially as we start looking at fossils. And fossils, while they're not the focus of this class, that would be prehistoric life, Geology 125, fossils are, once we start getting life on our planet, are how we have delineated the different periods and the different eras and eons then of Earth history. So as we're looking here at the Phanerozoic, and we'll see what those words mean in a little bit, very cool video I have for you on, how to understand the geologic time scale and what these terms mean. So I'll let someone else talk about that. We are looking at the age of invertebrates, the age of fish, the age of amphibians. And as I think about fossils, what's annoying here is this whole thing could be called the age of invertebrates. We still have, butterflies and beetles and stuff evolving all the time. They don't necessarily stop when we have higher, we don't like to use that term, but, more advanced, we don't like to use that term either, but other life forms showing up, invertebrates, fish. Things like salmon have actually evolved very, very recently. So, these terms are okay if they help you to remember the time span, but not so great as we think about the biodiversity. Anyway, so this is not to scale because here we go, looking at the whole Precambrian, which makes up, again, close to 9/10 of the history of our planet, and it's squashed into just this little bit because it's hard to delineate the sections because there really aren't complex fossils to look at. And then we're kind of thinking about the different life forms that occur. And again, these are the first ones, but we still have evolution of different forms all throughout this time span. Humans show up only here at the very, very end. Now, so we're looking at fossils here. We're looking at animal groups, which have helped us to define the different time spans, but this class is about the history of the Earth. So instead of fossils, we're focusing a bit more on the continents, on geology, on plate tectonics. So one of the cool things that we're going to be looking at then is how the continents have changed over Earth history. Here we are looking at the late Proterozoic. So we have a little arrow here about 650 million years ago. Arrow's not in the best place, but anyway. We are looking at a supercontinent. This would be a supercontinent called Rodinia. Actually, we're kind of leaving Rodinia, and the continents are actually pretty far apart at this point. They're starting to divide up, and they're becoming much further and further apart. And you can see the white outlines are showing us what these continents look like today, sort of. So Antarctica, Australia, and kind of see the shapes of these. Whereas, Laurentia here would be dealing with North America. So that's kind of Grenville province, for instance, that's kind of the ancestral Appalachian Mountains. So we're not really able to see a whole lot of North America. It's very much in the south. So this is what was going on before complex life began to evolve on our planet. Not a surprise then that most life, actually all life early on, was in the water. There's a lot of water, and we'll talk about why later on, a lot of ocean. Then as we go up into about 450 million years ago, we're looking at the Ordovician period, and we're going to, this is one that we're going to zoom in on later on in the semester because this is the age of our local Cincinnatian rocks. So here in northern Kentucky, southwestern Ohio, if you go in your backyard and you find these little, people think that they're like plant fossils or bone fossils or something. They're neither. They're all marine invertebrates from a shallow tropical sea about 450 million years ago. And we can look at that here with Laurentia. You can barely see that, but right above the P in Iapetus, so you kind of see, the only landmass in North America that's exposed during this time is up in northern Canada. All the rest of it is underwater. Right above that P in Iapetus is the Cincinnati, northern Kentucky area. So yeah, we're covered by a shallow sea, close to the equator, very tropical, lots of marine life there. So that's the Ordovician. As we start to get the very first fish evolving, and marine invertebrates though are dominating. Then we get into, sorry, I'm still working on learning my animations here. In the late Permian, this is, we can kind of consider this the age of amphibians, and actually I'd call the Permian more of the age of reptiles. Really, they were not quite at dinosaurs yet. That's going to be a little bit later. But during the Permian, we have something very cool happening. We have, look at this, big supercontinent come together. This is Pangaea. So we have all of our, pretty much all the continental mass colliding together. And the cool thing is Pangaea is not the first landmass. It's like the 7th or 8th, we're not really sure. But there have been multiple supercontinents, including Rodinia that I mentioned before Pangaea. Pangaea is the one we know the most about because it's the most recent. It's the last time all the continents collided together. So we can see where North America is, and yeah, there we go, our central Pangaean mountains, or now we call them the Appalachians, and there's bits and pieces of them in Scotland and Norway and Morocco and elsewhere we mentioned earlier. And as Pangaea comes together, something really interesting happens. We have the biggest mass extinction event that ever occurred on our planet. Now this predates the dinosaurs, and we will talk about mass extinctions in this course, because even though, yeah, that gets obviously into more biology, there are geological causes for major extinction events. There have been 5 throughout Earth history. The one that caused the dinosaurs to go extinct, it was like the 3rd biggest one or something. It's famous because dinosaurs, but this one is very cool, the late Permian or the end Permian event, because it would actually pave the way for the evolution of the dinosaurs. So then we have dinosaurs showing up throughout the Mesozoic. And then right about 66, 65 million years ago, we lose the non-bird dinosaurs in a big extinction event. But as you can see, going back 66 million years ago, the Earth doesn't look that different than it does today. The continents are kind of starting to get in their, in the right place, that we're familiar with today. So we have this whole age of reptiles, dinosaurs go extinct, as well as many, many other species. And then we have what we kind of call the age of mammals. Honestly, it could probably more appropriately be called the age of birds, because there's so many species of birds and they're incredibly successful. And here we go, 18,000 years ago, like no time ago, we had, people, we had different species of people, actually, many different kinds of humans living together, which many have gone extinct now, all except Homo sapiens, which is us. And that's going to be in the Pleistocene. So this is during the Ice Age, a glacial maximum here. And so we have humans going on, and that's it. So in a nutshell, that's kind of, how the tectonic plates have moved. And we'll talk about, actually we're going to spend a lot of time this semester talking about how we know that, because obviously no one was around, 650 million years ago to see how the continents were back then. So how do we know? And it's all about rocks. So we know a lot about rocks from what we'll talk about in the next video.